Hey there, everybody. My name is Eric Faisal,
Hi, I'm Jay Patel.
and we are here today to talk to you about the newly released Smart Screen SDK. And of course, this SDK helps device makers add visual responses to their Alexa built-in devices with screens. So just a little bit about us. I'm Eric. I'm a senior solutions architect with our Alexa Voice Services group. I actually started in Alexa Skills. So I worked in Alexa Skills for about 2 years. And then for the past year, I actually switched over to devices and work with device makers with screens such as TVs, set-top boxes, tablets, computing, and more to help add visual responses to Alexa.
Yeah, and I'm Jay Patel. I'm also a senior solutions architect here with Alexa Voice Services. I'm very passionate about developing things, consumer experiences with displays. I've worked on over-the-top experiences with folks like DirecTV. And prior to that, other projects that I've worked on are things like the voice remote for Xfinity and also defining standards for interactive television to enhance content and to let customers really perform voting and polling and even shopping directly on your television. So very excited to be here with Eric.
Yeah. Whereas you can see us, and so we're trying something a little bit different for this AVS webinar. In the past, they've been basically just been screen only, and so I think for the first time we're trying with to see us live. So we hope you guys like it. Just let us know. But a couple other housekeeping items. We are recording this, and an email will be sent to all of the participants afterwards with a link to the recording. And then questions. If you have questions, you can type them in to the webinar. We'll get those periodically. We'll check to see if there's any questions we can answer right away. Otherwise, we'll try to get to as many questions as we can get to at the end. So, all right, let's begin. So today we're going to talk a little bit about what that Smart Screen SDK is and the benefits. We'll talk a little bit about the Alexa presentation language, which is what powers the visuals behind all of these visual-based devices. Jay is going to talk a little bit about the architecture of building and running the Smart Screen SDK. We'll show you how you can actually build this yourself. We'll go through some of those steps, and then finally talk a little bit about things like certification, security, or dev kits, and then finally we'll take your questions at the end. So before we get in too much, since not everyone may know about what is the Alexa voice service, so it is a way for device makers to add Alexa to their product. And so if we take a look at what I have on the screen here, so all of these devices have something in common, and that is you can either control them with Alexa, or you can actually talk to Alexa on the device themselves. And the reason why we can do this with many what we call third-party products or companies that are not Amazon is because much of Alexa's processing and computing power is actually done in the cloud. And so what I want to do first is talk through, whenever you speak to Alexa, it's essentially the same process that happens on every utterance, whether it is an Amazon Echo device or a third-party device like a Sonos, or in this case like an LG TV. So for instance, if I say, well, I need an umbrella tomorrow, there's the first step that happens is something called ASR, or automatic speech recognition. So it's actually going to be taking, well, first it's going to be taking the audio from the device, sending it up to the Alexa voice service, and it's going to be taking the noises I'm making the syllables, the wa, the t, all those noises are also called phonemes. It's going to be taking those and transcribing them into text called speech recognition, automatic speech recognition. The next thing is to take that transcribed text and try to figure out what it is the customer is asking for. And we call this NLU. And Jay, what does NLU stand for?
Natural language understanding.
That's right. Yeah. And so in this case, it's more specific. It knows that I'm asking about weather, specifically rain, and with the date of tomorrow. So once it has this information, this NLU, this intent, it's going to then go to a skill to fulfill that request. And so in this case, Amazon has what we call a first-party weather skill. So it's going to make some call. It's probably going to be some sort of API or JSON call that's going to be taking in, my location, the date, etc., and going to be getting a response. And now just simply a JSON response is not that useful, and so it has to go to the final step. In this case, it's TTS, or text to speech. So it's actually going to be taking that response from fulfilling the request and then making it something human friendly. And so it's something like rain is likely in Seattle tomorrow. There's a 70% chance. Although actually, I think it's like a 90 or 100% chance.
Now it's converted to Samuel L. Jackson. So.
Oh, yeah, you do that too. Yeah. So anyways, we just wanted to mention this because anytime you speak to an Alexa device, it basically goes through these 4 steps, whether with a screen or without. So we're talking about screens.
So the Smart Screen SDK is something that we'd like to discuss, and it is really written on top of the AVS platform. So what it does is it allows you to really enable products within screens. They're to build really visual experiences very easily. So it has the ability to create compelling visual experiences on top of displays, similar to those that are seen really within the Echo Show family. So what we've done is we've added APL support, which we'll get into the internals of what Alexa presentation language is here shortly. But we've also provided code modules that make it very easy to help render and format Alexa visuals directly onto the screen, no matter what form factor you have of various devices, different kinds of resolutions for things that are varied in terms of devices as set-top boxes, televisions, tablets, round form screens, and even laptops. So device makers can really take full advantage with things like partial and full screen support, which are provided really out of the box. So here we're showing an example here where we say something like, Alexa, tell me a joke. And as you can see, we're saying it to either the LG TV directly through far field, or we're doing it to a remote control. And as Eric described, it goes to the ASR to the NLU and gets converted to text to speech. And directly, you see the actual answer to a joke, or a joke is, what's the robot's favorite dance move? The human.
Mm-hmm.
Yes. So let's go over some of the visual and compelling experiences that you can create. On the top left-hand section, we're showing one experience, which is, Alexa, give me some music. And here we can see that there's cover art that's being displayed. There's some level of controls that are actually being displayed directly on the display itself. You can go next or pause. Obviously, you can do this through voice, but it's really, really compelling to actually have that directly on the display. So we can also say something like, Alexa, give me the weather right now. We're in Seattle, so that actually is a weather report for Seattle here this next week. And it can have very good graphic art. On this example, there's a partial overlay that gets animated from the bottom up, and that overlay can be described on how quickly it moves and things like that, whether it's transparent, things like that. On the top right-hand corner, we have things that are very relevant to information. You'd like to ask Alexa something like, how tall is Mount Everest? And here you can see that the answer is provided, but also a wonderful high resolution picture of Mount Everest could be also displayed. This is an example of a full screen display. You can also do things like add things to shopping lists. I think folks are pretty used to adding shopping lists. And on the bottom left-hand corner, you'll see that fonts are pretty consistent, and those fonts are scaled based upon the device itself. We've kind of gone over the robot example, which is telling a joke. And that's again in full screen. And one of the things about the robot example is it also does the ability to be able to sync with audio, and we'll be showing that in the
later,
demo.
Yeah.
And the bottom right-hand corner is really the crux of APL and skills. This is a perfect example of a skill that gives you information about planets. We'll also show that in the future. But this has things like video, it has things like graphics, and it has a list of fonts. So these are some of the experiences that we will go into here in the future, but it gives you a good example.
And all of these were actually live from the SDK itself. These are all screenshots from the SDK. So if you build and run the SDK, you can actually get these exact visuals too.
And we will show you how to do that.
Yeah, cool.
Here moving forward. So let's go over some of the benefits and advantages of using the Smart Screen SDK. Since it is built on top of the AVS device SDK, it has all the advantages and capabilities of that, which are, we have a dev portal that has a lot of documentation. It's totally free. It's flexible. You can specifically build for visual experiences for devices with a screen, Echo Show-like experiences. The components are C++ based and available directly through GitHub with the sample application, and works with the Raspberry Pi. It works on macOS and Ubuntu. It comes with an implementation of the WakeWord engine that's for testing and development purposes. That is the engine that allows you to say Alexa, and it recognizes what you're saying. It also comes with the APL core engine and an example viewport, which makes it really easy for device makers to understand how to register capabilities like resolution. Since we supply the source code on GitHub, you have full visibility into the implementation. So device makers and developers can easily customize, extend, and integrate with maybe their own home screen. And it's not really an open source project per se, because we've done a lot of testing. We supply added features in a fully tested release every 4 to 6 weeks. So we have rigorous testing. And also, this same code is actually used in the field in the Echo Show itself. So it has been tested, tried and true, and has the benefits of thousands of hours of runtime.
Cool. So the way that all of these visuals are made possible is through something called APL, the Alexa Presentation Language. And actually, I see somebody was asking, how do you create visual experiences across devices of different screen sizes? And actually, this is the way. So with the Alexa Presentation Language, experience makers, so whether it's like for Amazon creating them, like for weather or for jokes, or for third-party skill developers, you'll actually receive some information about the device itself. For instance, how big it is, the dimensions, whether it's a round screen or not, etc. And then also, as a experience maker, when you create an APL document, which has similarities to, say, an HTML page with rich styling, APL also has styling, you can actually create responsive-like layouts. So for instance, if it is a small round hub, like an Echo Spot, you might only display, like in this example, just the picture in the background with some text on front. But if you have a very large viewport, something like a TV, whether it's a Fire TV or LG TV, you can actually make better use of that real estate. For instance, of the image on the left, text in the main section. And so ultimately, the APL Alexa Presentation Language is how experience makers can create Alexa visual responses across the different sizes. We're not going to go too much into APL on this talk. I can say that from on the Alexa skills team, there is a variety of APL courses that talk about it. More specifically, I think it's the Cakewalk course, which was released not too long ago, that also has APL support. And one last thing about APL, you can, in addition to just creating static documents and layouts, you can also support things like video, animations, video animations, SVG graphics. I think that covers a lot of it. So anyways, in terms of how APL works on the device, so for instance, when a customer says an utterance, so in this case, it's a third-party skill called Snow Call Me Past Status. So much of the flow is actually going to be the same. So that same ASR, NLU, and skill piece that I talked about, that's all the same. But where we start to differ is on the response. So in this case, for a skill, it's going to be having on these, there's a render document and an execute commands. Those are directives that come back in addition to just the standard TTS or text to speech. And what it's going to say is that in addition to just stating whatever the response is or what Alexa's voice is, we're also going to provide our APL document with the info, with our layout info, as well as any optional commands. And so in this case, once it finally returns, then Alexa will say something like Snow Call Me Past Eastbound, blah, 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 as well as show a visual response. I think I'll actually demo this skill a little bit later. In terms of what APL looks like, as I mentioned, it is JSON based, and it also contains a variety of components. So things like, we call them containers, images, text. We have things called frames. So there's a variety of components that are used, that are created. Components can be extended, placed next to each other, et cetera. Again, I'm trying not to go into too much detail about APL, but for instance, this is actually, for instance, the APL on the left gets translated and rendered into the display on the right by the Alexa Smart Screen SDK, or as well as devices like the Echo Show, et cetera. So with that, I think it's time to look at the SDK. So what I'm going to do is, I've got my Mac machine here, and
so as Eric is setting this up, he's actually doing this directly on his Macintosh, which he's already built the SDK, and we'll go over kind of all the components of building the SDK. He's gonna launch a browser, and on the browser we can directly actually call out commands. And at this point, we kind of show you some of the screenshots of some of the examples that we're going to do, but we're going to start off with maybe telling a joke.
Yeah, so Here we go. So on the left here, I've got my terminal. Now, if you've built with the AVS Device SDK before, this would actually be fairly similar. You also have our very rich GUI of our UI. I'm kidding on that part, but it gives you some basic information like, oh, there is a notification, it's connecting, what the state is, so it's an idle state. So as in it's not actually not processing or anything. And now in this case, when you first run the Smart Screen SDK, you'll get a view kind of like this. And if you're running on a Mac, by default, the wake word engine does not come included. I'll show you a version with it. And so you actually have to hit A before you speak. So I don't actually have to say Alexa in this case because
You have this day in history enabled.
There
Do
you
you
go.
want to open?
Apparently I ran a version with it already enabled. Okay, well, take back what I say. In this case, it's actually supporting both. It's supporting both A or the wake word. So, okay, let's try this. Tell me a joke. The suspense is really good.
What's the difference between a well-dressed cyclist and a scruffy guy on a tricycle? A tire.
Actually, as a cyclist, that's kind of okay. All right, but anyways, so kind of as Jay was talking about a little bit earlier. So one of the cool things. So obviously we've got the visual. We've got just setting the theme with the blue and the microphone on it as we're telling a joke. But then also what's cool too is that with the scrolling. And so if this was a static document and we just displayed the entire thing at once, we would be showing the punchline before it was read out. And so by using it's in APL, it's called a speak item, but we can actually synchronize the text reading along with the speech. So that's pretty cool.
That's great. That's perfect for karaoke.
Yeah. And so like another one, if you want to ask a question like Alexa, who is Albert Einstein?
Albert Einstein was a German-born theoretical physicist who developed the theory of relativity, one of the two pillars of modern physics.
I'm actually going to click. So if you click on here, it actually stops the speaking. We also see some of the attention. We call them attention states on the left side here. So in terms of when she was listening, etc. So what I also want to show is, so this is called the Smart Screen Landscape Large mode, but I can actually launch it in another version. So let's look at a partial screen functionality. So let's do, I'm going to run a slightly different command. So Control-C to kill it, run a new command, and I'm going to refresh my page just to, okay, connecting.
So as you can read, it says full screen plus lower third panel. As you get more familiar with the various naming of these different, what we call viewports, which are very well documented within GitHub, and we'll show it to you here moving forward, it will really become really important for developers and device makers to recognize that there are different ways that you can show things on the screen, especially if you're thinking about televisions and set-top boxes, and you have to think about how often the video is showing in the background. Yeah. So this is an example.
So I'm going to repeat the last utterance just to show the difference. Alexa, who is Albert Einstein?
Albert Einstein was a German-born theoretical. So
in this, again, I clicked it to pause the audio playback. In this case, so we're doing the partial or lower third panel. And so this is be really compelling for like a TV or set-top box. So maybe you're watching something on TV and you have a generic question, maybe on an actor or whatever it is, and you just want to get some quick information. It's nice to have that as an option.
And the animation is great. And as you can see, the actual fonts also are formatted in the proper way.
Yeah, let's try another TV landscape. And so
which one?
Let's try. Well, let's do Alexa. What's the weather?
In Seattle, it's 46 degrees Fahrenheit with cloudy skies. Today, you can look for lots of clouds with a high of 48 degrees.
So again, I'll click deposit, but so we also provide an option to roll in from the right. And likewise, if I were to ask about Albert Einstein, it would have showed up here as well. Now, even though we've got this partial panel from the right, there are still some experiences that will still be full screen. Let's try Alexa, play music by Mozart.
Shuffling songs by Wolfgang Amadeus Mozart on Amazon Music.
we're really fast today,
Yes.
apparently. So,
Well, here we go.
so I feel like this is
It's
a little bit of a somber mood. Yeah. So anyways, so this is our media player. So I'm actually gonna click pause. So I click pause there. I could also pause it by voice or say next by voice. And also what's on the left side here, so it's actually kind of interesting. If you run our AVS device SDK and you play music, you actually get quite a few pieces of information, some directives coming in. So you'll get information on like the album art, other metadata, like obviously what the track and title is. You'll also get information on, for instance, we are, well, I don't know, 10%, well, gosh, 5% into the song. So you actually get some information. I'm only running this in info as opposed to the full debug, but actually would give you some more information. So it's kind of neat there.
And the controls are great, actually. At the
Yeah.
bottom, so.
Yeah, they're nice. And so let's also do maybe two skills real quick, just as example. So Alexa, open Snoqualmie Pass. Oh, it went too fast. Okay, it's thinking already. Alexa, open Snoqualmie Pass status.
Snoqualmie Pass eastbound currently has no restrictions. Westbound, no restrictions.
Go ski.
The roadway is bare
Yeah.
and dry.
So background, Snoqualmie Pass is a mountain pass on Interstate 90, roughly an hour outside of Seattle where we are right now. And so obviously it's just saying that the pass is open because in the winter sometimes it gets snowy. But what's neat about this is one, I realized there was only 2 lines, but it did the line by line highlighting, so kind of similar to the Joe. And the other is actually shows visuals. So these are webcams from there, so you can actually see what the condition looks like. And the reason I bring this up is because yes, I mean, we love voice, we're voice first, but sometimes, well, I guess a picture is worth 1,000 words, and that, seeing the snow on the ground just adds a lot more to the experience. And so by implementing these visuals with your device can really, add to that customer experience. And then finally, we talked a little about the Space Explorer skill, so let's open that up. Alexa, open Space Explorer.
That's a great answer.
Yeah. This actually reminds me. I know The Expanse came out. Do you watch The Expanse?
I do. I love it.
And we're not paid by. That's not a paid promotion or anything. It's just it's fun to watch. Because I can even say something like, Alexa, take me to the outer planets.
Welcome to the outer solar system. Which planet would you like to visit?
Well, I would. Okay, well, apparently it's not responding very well, so our demo's going great. But I can also, there it is. It just needs a little bit. Just need to kick the tires a little bit. But well, let's do Jupiter. Alexa, take me to Jupiter.
Okay, leaving the outer solar system and heading to Jupiter.
And then it can also say, Alexa, tell me about it.
Jupiter is the 5th planet from our sun and is.
Pause. So pause the playback. So a couple things. One, this is actually video playing behind the scenes. There's video. That opening piece was a video as well. And then I didn't get into it now. Maybe if we have time, but actually this skill also has SVG graphics and animations. So there's quite a bit of options for experience creators, or skill developers with APL. And now this skill is not on the skill store, but it is actually available on GitHub, on the Alexa Labs GitHub.
That's great.
And so we'll try
everything.
Yeah. So you can actually see the full layouts, full responses if you want to create or copy or borrow and use inspire. I know that could be a loaded term, but no. The whole point of that skill is to try to inspire experienced developers to create rich and powerful experiences in APL. So
I think that's a great example of showing a skill that actually shows off a lot of different components, things like video and lists and things like that. So maybe we can dive a little deeper into what the software architecture is for the Smart Screen SDK and how we actually got some of these things working here. We talked about on the top-hand side, you'll see the AVS Device SDK. We really have 4 components as part of the software architecture: the AVS Device SDK, the compatibility agents, the APL Core Engine, and the APL Web View Host. The AVS Device SDK, we kind of went over initially. It's the root of making Alexa voice experiences work. We've added really 3 components really for the Smart Screen SDK to do these sort of visually compelling things. We have compatibility agents so that we can be somewhat working on older 1.1 display card technology, which some of you guys are familiar with. That technology will still work as it has worked in the past. At a high level, the APL templates are sent from the cloud directly to the client device. The compatibility agents make sure the device is capable of displaying the template itself. It knows this because the device itself registers the things that it can actually be capable of working on. This template is then sent to the APL core engine in JSON, and this is sent through a WebSocket, as you can see at the very bottom here, to a web view host, which renders and formats the elements to the browser itself, as Eric displayed in many of his demos. So let's review what these 3 major things are. Compatibility agents themselves are the key really to device makers to be able to serve multiple viewports and devices through identifying resolutions, full screen, partial screen, things like that. We've included a template runtime to, again, deal with old display card technology. And the APL core library and the APL core engine is disconnected with the APL web view host. And the reason why we did this, one subtle thing to note, is with that disconnect, you can allow any device maker really, because of the flexibility and customization that we provide with C++, to really create view hosts. Right now we create one in the web, but in theory you can create a view host native or specific to any display that it's rendered on moving forward. So that allows for a lot of flexibility here. On the device side, folks might be asking, well, what do we have to do as device makers to really enable some of this? As a device maker, really, you need to incorporate voice. So in order to incorporate voice, you have to have some sort of microphone within your device. That could be directly in the device itself, or it can actually be within the remote control. We've had folks partners work with both. So the WakeWord engine itself will be incorporated into the device. We provide the AVS client software, and with that, the device maker can register various types of capabilities through what we're calling viewports, which could be whether your device is a round or a hub or a tablet or a set-top box. And then the device maker really has the ability or the developer to create an APL experience either through a skill or through other means. And once that experience is actually sent over to your device, a lot of the hard work is actually done by the APL core engine, which is doing things like scaling graphics, doing things like scaling fonts. So a lot of that we provide directly to you within the Smart Screen SDK. So all of that really sounds great, but Eric, can you kind of take us through the build process? I know folks would want to start using this.
Yeah. So ultimately, if you want to start experimenting around with it, there's a couple steps. So first is you need to register a device with AVS, and I'll actually walk you through that a little bit. But that helps. You have to create a device. You have to register a device online through our developer console, so that AVS doesn't just let any random device connect and talk to it. You have to create a device, give it some information about it, and also get a security profile so that your device can actually connect to the Alexa voice service. You'll also need the 3 pieces that Jay was talking about. You'll need our AVS device SDK, currently version 1.15 for the Smart Screen SDK. If you may notice that it's not actually the most recent version of the AVS device SDK right now. We actually have a version 1.17. The Smart Screen SDK does not yet support 1.17, but it's in progress. And once we have updates, we'll push something out onto our GitHub page that indicates that. You also need the APL core version 1.2 and the Smart Screen SDK 2.0. And actually, all of this information is available on our GitHub page that I'll go to next. And you actually need to build it. So let's look at the GitHub page for a little bit. First of all, so it is at github.com/Alexa Smart Screen SDK with some dashes in between. The URL is up there, and maybe we can we'll try to get a helper to paste it into the chat if it's not already there. And so on here, you'll see a variety of pieces. So some information, generic information that we've kind of already talked to you about in this webinar, but the main things that I would probably recommend is one of the quick start guides. Certainly you can look through, this diagram looks familiar.
Yes, so we went over.
Yeah. And so like, for instance, on the macOS quick start guide.
So there are various quick start guides too, depending on the OS that you would like to work off of. So we have one for macOS, Ubuntu, and a third one.
Mm-hmm. Yeah, and so first it's talking about the AVS device, and it goes through a variety of commands. And actually, let me just take 1 minute real quick to talk about the AVS the developer portal. So first, if you're a skills developer, for instance, you already would have an account, but if not, you'll have to create an account, or if you're not an AVS developer already, you'll also have to create an account on developer.amazon.com. And then from there, you'll see you could either do skills or devices. In this case, this is the AVS console, and so you'll end up needing to create a product. In this case, I have just a sample product where you'll enter in some of your information on here. As an application, a device, or a gadget. In this case, it's probably more a device. It talks about, will you use a companion app, things like, a companion app to set it up. So if you're just prototyping, you don't really need to. And you can see that, I'm creating such an awesome device here. In this case, yeah, for prototyping, it doesn't matter too much what you put. Ultimately, what you want to get to is once you create it, you will get to the security profile. And ultimately, it's going to be using like the client ID and client secret up here. And this is just a throwaway account, so in case somebody tries to create a device in my name. But anyways, we have all these instructions on here, but ultimately you're going to want to create a security profile or download a security profile based off of the device that you create in this AVS console. Yep. And then through here, there's a lot of steps. And it may seem intimidating.
Yeah, initially it is, but what we really did try to do is make this step by step. And, the steps are really working on the AVS SDK, get your machine to work on an AVS SDK initially by using the security itself and run the sample. We also have made it fairly easy for folks to, to deal with gotchas. So we do have a technical page here that goes over some of the things that we've seen other folks get into, which is also directly a troubleshooting guide that helps folks. And a lot of it is really around microphone support for ALSA drivers for things like Raspberry Pi. So yes, initially it's daunting, but once you get the AVS SDK going, you then compile and download the APL core engine, and then thereafter you compile and download the Smart Screen SDK, which has its own sample, and that sample actually has the background screen as Eric showed, and thereafter you can just start using it and running it.
Yeah, and so again, there's a lot of steps on here, and again, it's not as bad as it seems. Ultimately, if you run into errors, it's usually best if you just kind of recheck your previous steps.
We do have the developer forum available for folks to create questions, and folks are actually monitoring that forum. So
yeah. Just the one thing I do want to call out, and this is the same whether you're using the regular AVS device SDK or the Smart Screen, is that you will ultimately need to authenticate the device, and then that is where we call it CBL, or code-based linking. And so when you're running your application, you'll actually get a 6-digit code. Many times the application will keep scrolling down. And you just have to scroll up until you see the code, and then you'll ultimately go to a website here where you enter in the 6-digit code, and that is what then authenticates your AVS device to your Amazon Alexa account. So it's kind of 2 steps. When you have to register your device, then you actually have to register the AVS device in the AVS console, and then you actually have to register that AVS device to your Amazon Alexa account, and then it actually would start showing up in your Alexa app. So
and you only have to do that one time.
That's true. Yeah, you could always deauthorize it either from the sample app itself or from the Alexa app if you're done prototyping, done working on it. But ultimately, you will eventually, with some persistence, not that much persistence, but a little bit of persistence, you'll ultimately get to the point where you can run it, and you will have the same the same experience I was having, and you can actually custom. And actually, let me talk just a little bit about those viewports. So, oops, actually, I don't want to be in Alexa. I want to be. We give some information. Optional considerations. Run the GUI client with predefined device visual characteristics and GUI configurations. So this is almost at the bottom of the page. But anyways, it's saying all of this information is under the module, modules, GUI config, GUI samples. I can get to that fairly quickly. Modules, GUI.
And this is to change things like partial screen, full screen. Once you get your sample working, you can change this config file to try to, as a device maker, sometimes you want to do full screen or partial screen, so you can do those kinds of tests, changing this configuration file. And as you get more familiar with it, we do have a lot of documentation associated with actual APIs as well around the Smart Screen SDK that will be provided here within GitHub as well.
Just a time check. I will probably not spend too much time on this. I just want to call out that we actually, in this, there is 2 windows, a TV overlay landscape and a TV full screen. And actually, if I keep scrolling down a little bit more on the TV overlay landscape, this is actually where we define the size. So we were actually saying 1920 pixels wide by 400 pixels tall. And so if you want to customize that, if you want to make it bigger, I mean, I don't know that I would make it that much bigger from a ratio wise from a UX, but I mean, if you want to experiment around, certainly you can modify this in here. But let's jump back to the slides, and then so we can get to your questions. I see a couple in there already.
So you actually did talk about a little bit about certification to a certain degree. You know, what we do is we do try to guide folks in terms of UX and things like that, in terms of how big the partial screen can be. So I want to talk a little bit about the certification process. We have several resources on the development portal to understand processes around certification and badging. The Alexa built-in badge it is really enhanced marketing program that incentivizes developers to produce high quality products. The built-in badges are also eligible for additional co-marketing opportunities. So I think it's something that device makers and maybe even some developers would like to be more involved with. The certification includes things like acoustic, functional, UX, and music within various kinds of resources that we provide. If you are interested in understanding more about certification, you can go directly to the dev portal and learn more about that.
And one quick call out is that there's really no difference in the acoustic certification for your visuals. The audio front end or the audio input is going to be roughly the same, but certainly functional and UX, those will be different if you have visuals on your device.
Yep, and since we do have visuals now, what we also have done is created a bunch of self-tests that are actually provided here on GitHub, and we also have documentation around viewports and UX information. Maybe you can look at the design guideline that we have in GitHub that talks a little bit more about view hosts and viewports that are around display cards and things like that. On the security side, as we know, security between the browser and the SDK itself is something that that needs to be thought out. In the sample application, we use WebSockets really to do that kind of communication between the two. But another consideration you should have is maybe some sort of identity token between those two. So we also have some guidelines around security that are present within the GitHub page. So with that, I also want to kind of let folks understand and know that within the AVS dev portal and within the same release cadence of this, we've had 2 real development kits to fast track development. The Alexa Smart Screen development kit is really a fully qualified solution that integrates hardware and software within one really high quality solution. As you can see here, it has a display. On the hardware side, it uses an ARM Cortex A53. The display is 4 inches. It has a 3 mic array for far field. On the solution side, on the software side, we actually have Alexa built-in wake word. We use Alexa wake word itself, the Amazon wake word. And we actually incorporate the Alexa Smart Screen SDK and a sample GUI. So for more information, we have a link there to get access to this thing. It really can really fast track your development. The second development kit that I'd like to tell you about is really a Broadcom kit, where we integrated a set-top box development kit for AVS, which really enables device makers to create set-top boxes with Alexa built in. It is really the first kit with a set-top box system SoC that supports far-field voice and leverages the Smart Screen SDK. So this really has the ability to do set-top box things like video services, more for a lean-back experience. You can access music, weather, shopping, and other services. So this is another kit that we'd like to let you guys be aware of, and was released along with this release. So with that said, we've presented a lot of information to you here today. We recognize that. I kind of want to go over some of the helpful links that we have. If you're new to AVS, we really have a getting started guide here on the dev portal. The first thing you really want to do is you want to create a developer account. And the link is provided here. When you log into the dev portal, we have many resources and documentation that you can get access to. But if you're specifically thinking about the Smart Screen SDK, the homepage for the SDK kind of gives you a lot of information on how to build and move forward in using this SDK. With that said, this SDK really has the intention of working with display type of hardware. We really would like for you to engage with us, use the SDK. Yeah. As we described, it's very flexible, it's customizable, and we really deliver all the C++ code for you to use. So what will you really voice enable with the Smart Screen SDK? And we're excited to see.
Absolutely.
With that, I think we'd like to open it up to questions.
Yeah, so we have some questions in here. Thanks everyone for your patience. So let me see if I can go. Well, want to try this one?
Sure.
The question is, how does integration work for AOSP builds? By the way, many of these questions, so some very great questions in there. I'm afraid we probably won't have fully satisfactory answers for all of them, but we can do your best. The integration for AOSP, we don't have a direct Android build for this SDK. So ultimately, it would basically require you kind of essentially developing it and porting it over yourself.
Yeah, so folks in the past have actually taken the C++ SDK itself and built JNI wrappers and created classes for that. We do have some partners who have done that. So it is, since we supply the code itself, you can do that. And creating things like ambient screens and creating customizable, since we do provide the C++ code, we're not just providing binary. It's really flexible for you guys to use within AOSP.
Okay, we talked. Is an HTML browser engine required? Take that.
Yeah, it actually isn't required. We kind of went over. You as a device maker can really take the JSON, create yourself your own viewport. We give you an example of a web-based viewport, but it is as we described, it is flexible, and we do recognize that sometimes you want to create these graphics on the screen very quickly.
There is some information in the APL core GitHub page on how view hosts are created. Admittedly, we're still pretty early in terms of what type of information we have, but yes, it is not required. HTML.
So maybe we'll take one that says, what is the difference between 1.1 display card technology and this new technology? The old technology is still very relevant, and we have a template compatibility agent where it does work. We're really trying to move towards this APL technology because it is much more flexible, and moving forward, it could work across many devices. As you guys are familiar, within display devices, the real difficulty is to make graphics really tailored to the size of your device. And with APL, since it is a template that's being sent through the cloud, we create some level of consistency and flexibility. But your old display card type of implementation is still very viable and can work with the Smart Screen SDK.
Should we take this one?
Sure.
Okay. So there's two questions. Maybe the same person asking about a live feed video of my door cam. No, not right now, but that would be a pretty neat feature if we could do that.
And as we described, we're doing 4 to 6 week cadences of new releases. We really are looking at the product backlog, and one of the things is WebRTC that we are looking into in terms of doing live standardized delivery of video. So the flexibility of the Smart Screen SDK will grow over time. This really is the first incarnation of it. And we are more than happy to listen to some of the features that you guys think would be really relevant.
Let me take this one. Someone's asking, how does the SDK work as a primary device interface? Can ODMs run full screen on device code alongside the SDK? Sort of. So I wouldn't necessarily say the SDK is meant as a full running standalone application. It's kind of meant to serve up visual responses as indicated with like the partial screen functionality. So it's which is really kind of designed with that was designed with like TV makers in mind. But certainly as kind of more functionality, Alexa functionality gets added to the screens, it could be served as a primary. But right now it's probably best as a companion. But it's something that I think we're looking into to see that if that is something that we could just run this as a standalone. But I would say as it is right now, probably not quite.
Yeah, I think that's a good answer.
There's another question. Can we access skills from the skill store through the Smart Screen SDK? Yes. So basically just about any skill you can run on like an Echo Show or Amazon Echo, you can run on the SDK. There is one small subtlety that I should make you aware of, that the skill must support APL, the Alexa Presentation Language, for it to render on the Smart Screen SDK. If it uses the older skill display cards, display templates, it actually does not render on the SDK. So if you happen to use the SDK and you're trying out some of your favorite skills, it may not render visually on the Smart Screen SDK, but if the skill supports APL, it will should behave virtually the same as it would on like an Echo Show product.
I think since we were talking about skills, I think this is right up your alley. We have a question that says, if I'm a developer and not a device maker, how can this help me?
Yeah, so as a skill developer, this is interesting. One, because it actually provides you as basically an Alexa visual device on your machine, on your laptop. So I have a couple of APL skills live in the skill store, and actually it's nice to be able to just use my laptop to actually test and debug the skill. Well, the skill developer portal does have a skill tester. The thing is, you still have to authenticate, you still have to log in, you still have to either type or hold down a button, like click a button to actually test it. Whereas this, especially if you have implemented the wake word, it becomes easier and faster to test. The other benefit too is that our hope is that we have some device makers that are able to take this, take our SDK, run with it either as is or expand upon it, and have more devices out there that support Alexa visual screens, because we do believe that it really enhances the experience. And so more more devices out there with screens means more places for your skill to be used. So that's our hope for it.
So I think at this point we'll maybe wrap it up a little bit and kind of let them know what the next steps are. Here we are going to send this recording over to you guys moving forward for the registrations. Is that correct?
Yes. Sorry, I was I was distracted looking at something else.
Yeah. So maybe next steps of how we're going to send this recording and what the next steps are. We would like to hear more from you guys in terms of whether this live recording was something that you like and would like to do here moving forward. And I think our recording will be sent as an email.
I think the was go to webinar was going to send out you will be receiving a recording of today's webinar of your email either today or tomorrow.
Today and
and the
tomorrow.
email will have a survey link with your feedback.
Okay.
That was totally just natural, right?
Yes,
I
yes,
didn't
it was,
need any
it
help.
was, it was. Well, we thank you for your time.
Yeah,
Definitely,
we're super excited about this. We hope you guys are as well. We hope you enjoyed this, and we're really excited to see what kind of devices you create, either as a hobbyist or even as a we call full-blown OEM. But yeah, we're really excited about this.
Yep.
And so
I think this is really exciting for device makers and SIs and ODMs to really kind of take these things and start really working on Echo Show-like experiences moving forward. We all recognize that visuals and voice are something that are going to work together here moving forward, and we're trying to make it easy for you guys.
Great.
Okay.
All right. Thanks, everyone.